Alright, folks, let's do this. Need to talk about a very important topic today, which is how do we do coordinate transformation? So if you look back in the notes from our class, you know that to transfer between different coordinates for the EK to local to global, you need this rotation matrix, which is R, and then you combine it to the big T matrix. But that's all simple. But the key is to get R. And R, what is it? It is a 3x3 matrix that if you time that with a vector from the old system, it can change it to the vector in the new system. Here we say it's like prime system versus non-prime system. In our matrix application, the prime system is whatever is along with your member, and the not prime system is the global. And we also said that in most finite element code, the z is the gravity location, so z is vertical. And then x, y, they have to follow the right-hand rule. If you do x cross y, you get z. Yeah, just get your right hand out, and you know yz is x and zx is y. Okay. So how do we do that? We need to kind of align it, and then so basically, because our matrix is made of directional cosines, so if we just find the 3 unit vectors, like one is aligned with ij, which is our x prime, and another is aligned with the weak bending axis of the ij, which is our new z, our like local z prime, and then another with the strong bending axis of your beam, which is local y prime, then we'll be fine. But yeah, how to do that? Couple of steps, and those steps are extremely easy to program in MATLAB. If you know the location of I, J, and your angle of rho. Remember that guy? Angle of rho, okay? So the first step, I guess everybody know how to do this, is to get a unit vector in X. If I tell you where I is and where J is, you just calculate the length and do the subtraction, then divide that by length. Yeah, okay, well, you got a directional cosine along X prime, and then that is also the component of a unit vector in X prime. Then the next one is kind of tricky, because you remember the angle of rho is, by our specification, or by most of convention of finite element software, we need to start counting angle of rho when the weak bending axis and x prime x form a plane that is vertical. That's our starting point to count phi. But yeah, how do I do that? Yeah, let's go to that starting place first. So this is kind of a math. It's kind of tricky. The first one is that you're going to cross z with x. Not x prime with z, but z with x prime, because, yeah, right-hand rule, you want to get a y bar, you got to do zx. Then you cross it. Remember, yeah, you cross this thing, then you got a vector that's perpendicular to both of them in another direction, which you get y bar. Okay, so, it will be horizontal. You're like, why is it horizontal? Yeah, because it's perpendicular to z. Z is vertical. Okay, and it's perpendicular to x. So we now got a kind of system like x prime y bar z. You're like, oh, can I use that? No, because z is not perpendicular to x. For some coordinate system to be actually qualified as a Cartesian system, you need the 3 axes to be perpendicular to each other. I mean, so you're like, okay, now what? Oh, that's simple. You just now cross your x bar with your newly defined y bar. X, y, then it'll give you a vector that is perpendicular to both. Okay. And also, it happens that because of the existence of y bar, the plane of z bar and x prime will be, because cross and everything, will be perpendicular to y bar. But y bar is horizontal, so this is the entire plane z bar x prime plane will be vertical. And then, gee, okay, you're like, yeah, this is great. Because this is exactly the starting position. We want to start rotate this thing to get our final position. If you tell me the angle of rho, right? For most of the beams, yeah, angle of rho will be 0, then you're here. But if not, you just like rotate those two guys by angle of rho phi along or about x prime. Right hand rule again, angle of phi is positive, you rotate it this way. If it's negative, you rotate it that way. But most of the time it's going to be positive, and then you rotate it. Then you got your x prime, y prime, z prime system. That's it. If you look at every single one of these, it is actually very easy to program in MATLAB. The unit vector you can do, the crossing, cross product, that's just a very fundamental thing in MATLAB. And then you cross it again. Then this rotation, you're like, how am I going to rotate? Yeah, use the rotation matrix. I think, yeah, I'm going to kind of give you another video where I'm going to show you. I'm going to also talk about it in the class when I came back. Okay, how do you apply another like rotational matrix to rotate this system into this phi? Another thing to take note is that for everything to be in a unit vector, you need to normalize everything as you go. Like the y bar need to be normalized, which means you want to turn it into a unit vector, because otherwise, its component is not directional cosines. The z bar need to be normalized. Then when you slice and dice through everything, then x, y, z will be normalized. Their component will be directional cosines, and you can just lay them up nicely. Then you got your rotational matrix R. All right, we'll see you when we get back. We'll talk about this. Thank you.